Hello viewers, I am Kausalya. Today we are going to solve problems in exercise 12.3. Problem 9. In figure, AB and CD are two diameters of a circle with center O perpendicular to each other, and OD is the diameter of the smaller circle. So here you see the diagram is given, right? AB and CD are the two diameters of the circle, right? So this is one diameter and this is one diameter. And this OD is the diameter of the smaller circle, right? It is obvious from the diagram. Next, if OA is equal to 7 centimeter, find the area of the shadowed region. If OA, right? So here if OA is 7 centimeter, we have to find the area of the shadowed regions. So here this is one shadowed region and this is the another shadowed region, right? So here in this case, you see the value of OA is 7. Then what about the value of OD? It is obviously 7 because OA is nothing but radius, right? It is the line which connects the center to a point on the circumference of the circle. So OA is radius. Similarly, OD is also a radius, OB is also a radius, and OC is also a radius. So OA is equal to OD. Therefore, the value of OD is 7, right? So here OD is nothing but it is the diameter of the smaller circle. Then what about the radius? So if OD is equal to 7, then obviously the radius of the smaller circle is 7 by 2, right? So as we know the radius, we can easily calculate the area of the circle. So here area of the circle is given by pi r square. So here the value of pi is 22 by 7 and the value of r is 7 by 2, right? So when you solve, finally we are ending up with the answer 77 by 2 centimeter square because it is area, right? Now we have find out this area. Okay, now we have to find this area. So how to find this area? So in this case, when you look at this part, right? So this ABC is a semicircle, right? Then obviously, you see this ABC, this point, there is a triangle also. So once you find the area of the semicircle and area of the triangle, right? You have to calculate these two things. Then when you subtract the area of the triangle from the area of the semicircle, then it is nothing but it is the area of the shadowed portion, right? So here area of the shadowed region is given by area of the semicircle minus area of the triangle. So what is the formula for semicircle? It is pi r square by 2 and area of the triangle is of b into h, right? So here the value of pi is 22 by 7, right? And what about the value of r here? You see again, for this semicircle, this OC is the radius, right? So here the value of OC is, as we already discussed, OA, even we can write it. OA is equal to OD, which is equal to OC, which is equal to 7 centimeter, right? So the value of the radius of the semicircle is, it is 7, right? So here the value of this radius is 7. So just substitute the values over here. So 22 by 7 into the r is 7 here. So 7 into 7 by 2 minus here 1 by 2 into base into height. So what is the value of base here? You see this is the base of your triangle. So what is its value here? This OA is 7 and this OB is also 7. Right, so OA plus OB forms the base of the triangle, right? OA plus OB, they form the base of the triangle. So here the value is 7 plus 7, so which is equal to 14 centimeter, right? So here just again substitute the values, 1 by 2 into 14 into 7. Again, when you simplify, here we are ending up with the answer as 28 centimeter square, right? Again, this is an area. So here it is 28 centimeter square. So now the question is, you have to find the area of the shadowed region, right? So here total area of the shaded region is nothing but you have to add the area of the smaller circle with this new area what we have calculated, right? So total area of the shaded region is area of the circle plus the shaded part in ABC, right? So here it is 77 by 2 plus 28. So when you simplify, we are ending up with the answer as 66.5 centimeters square, right? Our next problem is problem number 10. So here the problem is the area of an equilateral triangle ABC is this value. With each vertex of the triangle as center, a circle is drawn with radius equal to half the length of the side of the triangle. So here the thing is we have an equilateral triangle, right? So we have an equilateral triangle like this. With each vertex, right? What do you mean by vertex here? So this is one vertex, this is one vertex, and this is one vertex. With each vertex of the triangle as center, right? A circle is drawn. So with this vertex as center, we are drawing a circle. Similarly, with this vertex as center, again we are drawing a circle. Again with this vertex, we are drawing a circle, right? So here a circle is drawn with radius. You see the radius value is half the length of the side of the triangle, right? So if this is 4, for example, if the length is 4, then what about the radius of the circle? It is obviously 2. Okay, just I am quoting here for an example for your better understanding, right? So now we have to find the area of the shaded region, and here we have to take pi as 3.14 and root 3 as 1.73205. Okay, they are clearly mentioned in the problem. So here you see this is our shaded region, right? So how to find this area? So the only thing is, you see, it's very simple. You have to find this total area of the triangle, and then you have to subtract this area and this area. So from this diagram you can guess, right, what it is. Here we are having two radii and a enclosed path. So obviously this is a sector, right? So first we start with finding area of a triangle. So since this is an equilateral triangle, because it is given in the problem, so the formula is root 3 by 4 a square. So the value of area is given in the problem, so just take it as such. 17320.5 is equal to root 3 by 4 a square. So a is nothing but this is the side of the triangle, right? So I want to find a. So I am keeping a square here as such, and I am moving this root 3 by 4 to the left hand side. So whenever this is moved to the left hand side, it becomes 4 by root 3, right? So in the place of root 3, here the root 3 should be taken as 1.73205. It is mentioned in the problem. So just take it as such, right? So again you see, in order to remove the decimal points, because it will make our calculation a bit simpler. So how many values are there after this dot? 1, 2, 3, 4, 5. So here I am multiplying by, you see, 1 lakh. And that is I am multiplying and dividing by 1 lakh, right? So here 1, 5 zeros, and here again 1 with 5 zeros. So what happens to the denominator? You see, this dot gets eliminated. So I am having 173205. So here what happened? After this dot, I am having only one digit. So here there will be totally 4 zeros at the back without this digit, without this dot. So it is 173205 with 4 zeros, right? Because this one dot for this 1 0 will go off and there will be 4 zeros. So into 4 equal to a square. So here 1 with 4 zeros into 4 is nothing but 4 with 4 zeros equal to a square, right? So what about the value of a? A is nothing but 200, right? When you take square root of this 40,000, we will be getting 200. So what is a? A is nothing but it is the side of the equilateral triangle, right? So the side of the equilateral triangle is 200. What about the radius? Because you see it is given in the problem. radius equal to half the length of the side of the triangle, right? Radius is equal to half the length of the side. So here the length of the side is, it is 200. So what about the radius? It is 200 by 2, which is nothing but 100 centimeter, right? So now we have calculated the radius of the circle. Then again, when you look back at the diagram, you see, when you look back at this diagram, now we have calculated this radii, right? So if we know these two values, we can easily calculate the area of the sector, right? So this is 100 centimeter and again this is 100 centimeter. What about the angle between these two? Can you make a guess here? So the angle between, that is angle of an equilateral triangle, is 60 degree. Okay, here it is 60, here it is 60, and again here it is 60. So here it is 60 degrees and here it is 100 centimeter, here it is 100 centimeter. So we can easily calculate the area of the sector, right? So area of the sector is given by theta by 360 degree into pi r square. So theta is 60 and the radius is 100, right? Even we can draw the diagram here because it will make simpler. Okay, you can easily understand. So this is 100 centimeter, this is 100 centimeter, and this is the respective sector. So when you solve this, you see finally we are ending up with the answer as 15700 centimeter square, right? So here the area of the single sector is given by this value, right? So when you look back at the problem, how many sectors do we have? You see, this is one sector and this is one sector and this is another sector. So totally I have 3 sectors here. So we have to multiply the value by 3. So when you multiply this value by 3, right, here I am getting the answer as 15700 centimeter square, right? So the area of the shaded region is given by area of the triangle minus area of the 3 sectors, right? Here even you can write area of triangle minus area of the 3 sectors. So here finally we are ending up with the answer as 1620.5 centimeter square, right? So here comes the end of this video. If you have any doubt, let me know in the comment section. Thank you.